Hi, I'm Toby from AWS and welcome to This Is My Architecture. I'm joined today by George from Sparkpost. Hi George.
Hi Toby, how are you?
I'm fine. Welcome to reInvent.
Thank you.
Tell me, what does Sparkpost do?
So Sparkpost is the world leader in email delivery. So we help our customers get critical business email communications to their customers. Things like password resets, transaction notifications, marketing communication, all of those types of mail flows.
Great, okay. And the system we're going to look at here, is this mostly for outbound mail, is it?
Yeah, absolutely. So when we look at the system, we have customers inject mail into the system that they want us to manage for them. And they do that either over SMTP or over a REST API. That comes into an ELB, which splits off that mail into a cluster of MTAs, which handle things like templatizing mail, adding click wrapping links, and then managing the actual sending of that mail. One of the critical parts of mail, though, is that the reputation of the mail that you're sending and its ability to be delivered is pretty tightly bound to the IP that it comes from. And so we use a SMTP proxy to manage that EIP assignment so that we can decouple the EIP assignment from the heavy compute-intensive load within the MTA. So that mail then flows out through the proxy to the outside world.
Right, so this is your application level proxy. This is the actual mail transfer agent that's going to send to external hosts out there in the internet. Yep.
Right. Technically, it's actually a network layer proxy, but yes.
Go on. Okay, great. And I see we've got some event data here. What are you using SQS for?
Right, so we use SQS as a critical part of our ETL for collecting and transferring reporting data to customers, both through dashboards as well as webhooks.
Okay. So you're going to have some other databases and other systems downstream of that?
Exactly.
Sure, okay. So one thing I'm interested in is, it looks like a neat solution. Tell me, is this something that you've evolved over time? Was it born like this, or what's been the evolution?
Yeah, so this solution has evolved quite a bit since we started. Initially, we were binding EIPs directly to our MTA nodes.
Right, so you had all those EIPs on the MTA cluster here.
Exactly. Yep. And that presented a couple different challenges to us. One, AWS limits the number of EIPs that are available on a given instance by instance type. And what that caused was this creation of islands, right? As our customer base grew and as individual customer usage grew, we needed to have a lot more logic up in the ELB around where a message needed to flow to be able to even come out of, to even be able to come out of the right EIP in the first place.
Right. So you almost built a monolith of your own there.
Right. Exactly. Yep. And that was intractable. And so what we wanted to achieve was the ability within the MTA to have any MTA handle any message that flowed into the system. And so the way that we do that is by having this network layer SMTP proxy tier that is completely configurationless. So when we get a new EIP from AWS and we bind it to an ENI on this proxy, we then take a configuration fragment describing how to actually get access to that IP and what proxy nodes that are associated with it, and we bake that back into the MTA configuration here. So this is completely configurationless, completely stateless.
So this proxy cluster here, what sort of instances do you use with EC2?
We use C48XLs there, and the C48XLs allow for binding of up to 240 EIPs across up to 30 ENIs.
Wow.
And that's actually the fundamental scaling limit for that cluster. So we don't approach network saturation or CPU saturation, storage saturation. It's purely on the number of EIPs that are allocatable to that instance.
Great. Okay. Well, thanks very much, George, for sharing.
My pleasure.
Okay. And thanks for watching. This is my architecture.